This is a question on codominance and cattle fur colour. So if we just remind ourselves, codominance is where both alleles are expressed in the phenotype. So they're expressed equally. Okay, so in cattle fur colour, we have these two alleles. So in codominance, we show that the allele is present on the phenotype. So this C represents the phenotype, the colour, and the W represents white. And then we've got the C for the colour again, and then in superscript, the R for the red. So three phenotypes here. CW genotype would mean a cattle with white fur. CR would be cattle with red fur. And then a combination of the two, CW, so heterozygous, means that the cattle are rowan. So they appear a mixture of the white and the red. So in this question, a rowan cow, so female, is mated with a white bull male. Okay, so draw a genetic diagram to determine the probability of producing rowan offspring. So if we look at this again, so we have parental phenotypes, so we have a rowan cow mated with a white bull. The parental genotype, if we go back to this, so the rowan cow will be CR, CW, and the white bull would be CW, CW. So rowan is heterozygous, the white bull is homozygous for that white allele. The gametes, so after meiosis, these alleles are separated. So we're going to have one CR and one CW. Circles just represent that they are gametes. And CW. Okay. Then we draw the Punnett square to find out what the F1 genotypes will be. So if we put the female at the top, CR, CW, and then the male can only produce these white alleles. We'll only do it once. Here. So we're going to have one rowan offspring, and for every one white offspring. So the ratio, the F1 phenotype can either be rowan or white. And the ratio will always be 1 or 0.5 as a decimal to 1, 0.5 as a decimal. So the probability of having rowan offspring, and it just says offspring here, it doesn't say male or female, would be 0.5, or that can be expressed as a fraction, so half, or could be expressed as a percentage, so 50%. And that was a codominance question.